I think we're there. Good evening, everyone, and thank you for coming tonight for the third evening lecture in the spring series, sponsored by the North Wessex Downs National Landscape. We are very fortunate this evening to have with us Julian from the Hendred Estate to talk about sustainable farming and working with nature and the environment. Your microphones are muted and cameras are off to avoid any accidental interruption. There will be an opportunity to ask Julian questions at the end of his talk using the chat function. But without further ado, Julian, if you're happy and ready, over to you. Thank you.
Brilliant, thanks, Dan. Good evening, everybody. I'm going to talk to you about farming on the Hendred Estate, which is obviously connected. This is talk about the Ridgeway, a series of talks about the Ridgeway. Obviously, the Ridgeway is a great ribbon track that runs through a great load of farmland on the Downs, and obviously what goes on in the farmland is essentially creates the very nature of what the Ridgeway is, what's going on in the farmland around it. So I'm going to talk about farming on the Hendred Estate, but also it's going to be much broader than that. I'm going to talk about some of the reasons why we're doing things that we're doing, and also to try and keep it in context with the Ridgeway. I'm imagining a lay audience of people that walk on the Ridgeway, and I'm trying to make my talk almost a bit like an old-fashioned I Spy book, where you're on a car journey going on a holiday back in the day, and you're spotting things out the window as people are going down the Ridgeway. They might be able to spot things that are going on and techniques that are going on in the farmland either side of the Ridgeway, which I'm going to sort of help explain why certain things are going on, which might not be apparent to a lay person. So let's go. I've got loads to get through. Hopefully any English teachers in the audience are giving me 10 out of 10 for my schoolboy alliteration in the title. I was trying to think what farming's all about at the moment, and the number one really is staying solvent. It's all about soil. It's all about societal scrutiny. It's all about striving for sustainable solutions and also trying to live in harmony with nature. So I managed to get my bit of alliteration in there. Right. What does farming look like, or what did farming used to look like? A bit of background first. This is probably what farming used to look like back in the day, 20, 30, 40, 50 years ago. A lot of different things going on, lots of animals, lots of people, nice extensive systems. What does it tend to look like today? Oh, sorry, the other thing is a lot of sheep on the Downs back in the day. The one in the top right corner is an old picture of a sheep fair in East Ilsley, probably over 100 years ago. We still do use the Ridgeway for droving sheep occasionally. That bottom right picture is my eldest daughter droving our sheep along the Ridgeway a few years back. So there's still sheep around, but not as many as there used to be. Farming on the Ridgeway now tends to look like this, I feel, which is large scale, specialised and intensive, big arable fields, and livestock farming, rather than sheep wandering about on the Downs, tends to look like this. Again, large scale, intensive and very specialised, and often indoors with livestock. So why does farming look like that now, different to 50, 60, 70 years ago? Basically because farmers don't make any money. Don't worry about the figures on this too much, but this is a slide of me in the top left in 1978, which was the first year I sold wheat when I was about 14. My dad was paying me about £15 a week, and I was on a little old tractor, and we were selling wheat for about £100 a tonne. I've inflation adjusted those figures to give my wages £80 a week in 2025, sitting on a tractor and drill worth about £3,200, and we were selling wheat for £535 a tonne. Today, my operator's on about £850 a week. The drilling rig cost about £260,000, and we're selling wheat for £175 a tonne compared to £535 a tonne 45 years ago. Basically, costs have done that, and our output price has done that. And it's the same with inputs. Don't worry about the figures on this. It's just the right-hand column, really. That's the seed, sprays and fertilisers. on wheat and barley, oilseed rape crops from 1994, so that's about 30 years. The increase above inflation is between 25 and 75%. So again, input costs going up, but our end product value going down. And this is why you hear on the news a lot farmers complaining about the inheritance tax thing at the moment, because just again, a little bit of background on that, assuming you're a lay audience, farmers are sitting on massive asset values, but you can't generate very much profit. So paying taxes is quite difficult. Right, let's just go again. Types of farming, those intensive types of farming that I showed here, arable and livestock farming, I tend to call those industrial agriculture, which is on the right hand side of that slide. And I think agriculture's got a slider. You've got industrial agriculture on the right hand side, and you've got organic farming on the left hand side, and somewhere in between you've got farming, which is badged as lots of things at the moment: regenerative agriculture, sustainable agriculture, agroecological farming. But really it's good old-fashioned mixed farming. It's where people have realized that industrial agriculture is not sustainable, and so they're trying to have more sustainable systems without going fully organic. So let's just go back to industrial agriculture. It's been a massive success. That little red circle, little red oval in the middle, is about the Second World War. Total agricultural land in blue has stayed the same or dropped off a little bit. Population's gone up in brown, and global food production has gone up, the pink line. Massive, massive, massive success story. Apart from, as my little guy in the top right hand corner is contemplating, no one's really factored in the environmental damage and the lack of sustainability for industrial agriculture. This is why people are thinking about different systems. Let me give you an analogy, which is one of my favourite analogies, and then we can move forward with actually what we're trying to do. Think about the BMW factory in Oxford, and they're producing minis on a production line, selling minis for a profit, and BMW are diverting some of that profit to maintain the factory premises. They'd be mad not to. If the roof fell in on the production line, that's their business gone. So they paint the factory, they fix the gutters, they fix the roof, they divert profit to maintain their factory premises so the production line can carry on. I use this analogy to describe all the environmental ecosystems that we work in as our factory premises, like the soil, the biodiversity, the sunshine, the rainfall, everything that we're working in, nature around us, is our factory premises, and our food production is the production line. And industrial agriculture has failed to maintain the factory premises. Industrial agriculture on the left has concentrated on intensive food production, and it's really forgotten that we have to maintain our factory premises. Partly it's because we didn't realise we were damaging them so badly, and partly because we're not making enough profit, as I alluded to at the start. So unlike Mr. BMW, who can divert some profit, we haven't got enough to divert. So industrial agriculture really has pretty well wreaked havoc on the environment. Hence headlines like this. I mean, that middle one: global food system is the biggest single contributor to biodiversity loss, deforestation, drought, freshwater pollution, and the collapse of aquatic wildlife. I mean, it's a bit of a damning indictment, really, when you look into a lot of the environmental damage that farming's done. Right, on to us. We're trying to be part of the solution. So where we're trying to sit is in that red circle somewhere. We, for various reasons, we don't want to go fully organic, but we want to have a more sustainable system. So we're trying to sit in, I'll call it regenerative agriculture, because that's like the buzzword at the moment. That's where we're trying to pitch our system. So we need to just look at it a bit more broadly first. We need to look at soil, because that's the crux to everything. Soil, people don't think that's very important really, but this picture really shows that it's just the skin the topsoil is. That's what's actually growing the food. And it's interesting, in the best Blue Peter traditions, when I do a talk, I do an apple analogy, but I haven't got time to do it tonight, so I've prepared one earlier. This is the planet, this apple, and if you take out the sea, the mountains, the cities, the roads, and everything else, and you peel it, you end up peeling a 30-second, I don't know if you can see this or not, you end up peeling a 30-second of the apple. And so effectively you've got 7-8 billion people living on apple, and they're sustained by that little strip of skin on a 30-second of the apple, 3% of the planet's surface. So it's super important, and it's getting degraded. Industrial agriculture degrades it mainly because it burns organic matter out of the soil. We'll see a bit later when I talk about the soil organic matter. That soil in the top left corner is nice and dark brown. It's healthy. It's got lots of carbon in. Industrial agriculture tends to mine the carbon out of soils and turn them into deserts effectively. And I often think that if there was space aliens hovering above us and they'd been sitting there for like a few thousand years, and then they went back to their planet and all the aliens on the planet said, oh, what are those humans species? What are they? They might say, oh, they're a desert making species, because if they observed us over thousands of years, they'd basically see the planet turning from good soil to bad soil. And another way of looking at it, like in the top right there, the soil's a deposit bank account really, because it's fertility to grow food for the future. And by destroying soil health, we basically we borrow fertility from the future, and we're sort of emptying the deposit bank account. That's quite important because soil is quite important to our farming system. So I had to give you that background. Hence the damage to soil. You get headlines like this, that left-hand headline from a few years back, Britain facing food crisis as world soil vanishes in 60 years. And then that right-hand one, fertility of world soil reaching a peak that will threaten food supplies, scientists warn. So there's all this worry about food and declining soil health. That's just one of the ways that soil can be impacted. That's erosion. That left-hand one is amazing. That's a satellite picture of the UK in 2012. Look at the topsoil around the Wash, Bristol Channel. Basically topsoil washed into the sea because of poor farming practices. And then again, that right-hand shot, just eroded soil, again, poor farming practices there. So what a lot of what we're trying to do on Hendred Estate is, sorry, you'll see pretty pictures in a minute, is farm our soil so it's healthy. And this is what I call my healthy soil recipe card. Don't worry about reading it because I'm going to go through it one at a time. My healthy soil recipe card, I want good structure and I want high organic matter. And so these little boxes in blue and red are how I achieve that. So let's just do them one at a time. So let's just do that first one there. Grow high yielding crops and cover crops to maximize carbon sequestration into soil via photosynthesis. I don't really see myself as a farmer. I see myself as a photosynthesis facilitator. Again, not wanting to teach grandma to suck eggs because you've probably all done O-level or A-level biology, but photosynthesis is obviously turning sunshine, carbon dioxide, and water and nutrients out of the soil into plant growth. But products of photosynthesis, plants only need about 50-60% of the products of photosynthesis to grow, and the rest of them are pumped down through the root system into the soil underground to feed the soil ecosystem. So this is how nature builds carbon in soil via photosynthesis, and I sort of view it as green plants punching snacks to my soil community. So I've got that little picture on the right there of Augustus Gloop with his chocolate from Charlie in the Chocolate Factory, and it's almost like yummy liquid carbon from root exudates, snacks on demand for the soil community. So all I'm trying to do all the time is trying to punch carbon into the soil, and that's what drives our farming system. Because there's lots of, I could have a whole talk on soil, but there's loads of things going on in soil. Earthworms are one of my favourite things, particularly on the left. These deep burrowing, the vertical channel, the deep burrowing earthworms, they're providing drainage channels, helping in these heavy rain events we get, and a lot of flooding in towns and cities. If farmland's soil's in good health, a lot of the water percolates through the soil rather than runs off the top into drains and flooding cities. And also the worms are really good at bringing the debris, straw and different things and cover crop debris down into the soil system, breaking it down and letting all the other soil organisms eat it. So that's just one of the things that's fantastic. My other favourite thing are mycorrhizal fungi. I just love these babies. It's a 450 million year old relationship with plants, mycorrhizal fungi. They basically live in a symbiotic relationship with plant roots. That big picture is basically a plant root, and all the filaments coming off are mycorrhizal fungi threads. They live in a symbiotic relationship. The plant feeds them carbon via photosynthesis, and the mycorrhizal fungi effectively acts like a massive increased root surface area. It's almost like the plant's got loads more roots, and it brings in nutrients and water to help the plant grow. So they're both helping each other out. There's loads of things like this going on in soil. Soil is just, nobody really fully understands soil. And again, you might not see this, but very quickly, I don't know if you can see this, you probably can't see it. There's a teaspoonful of soil. If I was out in a live audience, I'd ask the question, how many microorganisms do you think are in that teaspoon? Obviously, I can't do that. So a healthy bit of soil, a teaspoon, might have about 7 billion microorganisms in it. The number of people that are on the planet effectively in that teaspoonful of soil, if we look after it. That's what we're trying to do on Hendred Estate. Right, let's give you some prettier pictures. So one of the ways of doing this, and again, these are sort of I spy things now to sort of notice when you're walking on the Ridgeway. Traditionally, particularly in the winter, that inset of the ploughed fields would be ploughed over the winter, ready for spring cropping, or stubbles would be just left bare like the main picture. But that's like, nature doesn't really leave things not growing and leave bare soil. So what we do is cover cropping. The top right inset picture, straight after harvest, if there's any fields that are going into spring cropping, we plant them with multi-species cover crops, which means I'm keeping the photosynthesis going and putting carbon into the soil and protecting the surface as well from erosion. If you can imagine that ploughed field, if heavy rainfall events on a downland scenario, lots of soil erosion. So again, that's something you might see close to the Ridgeway, because regenerative agriculture is really, a lot of people are getting the message now that industrial agriculture isn't really working. And so more and more people are sort of moving into these systems. So it's something you might see increasingly more of in the winter, walking down the Ridgeway, fields with cover crops on, things in flower at strange times of the year, because cover crops might be flowering in October, November, and you might wonder what they are. They're cover crops. And then what we tend to do, we tend to put livestock on cover crops as well. And so this is interesting because livestock sort of disappeared off the downs and they turned into big arable prairies by the Ridgeway. But now you might see livestock coming back a little bit because people are bringing sheep in particular to graze the cover crops that they're growing. And so in some ways, the nature of the farmland around the Ridgeway is changing. The stock is tending to come back a little bit. What we do with the cover crops as well, it goes back to the soil health. We grow multi-species because if we've got multi-species growing rather than a single species, it's a bit like the Brazilian rainforest. The more things going on, the healthier the ecosystem is, and different plants root systems host different mycorrhizal fungi and different organisms living in the soil. These 7 billion organisms per teaspoonful of soil, they all thrive in slightly different environments and slightly different niches. And so if we can have diverse root systems, we're making the soil healthier. It's a bit like people having a nice balanced diet rather than living on chips. This is just a bit of a side one. Again, with these big cover crops that grow, we then have to plant spring crops like spring barley in the spring, so we have to kill them somehow. And again, it's a subject of a whole talk, glyphosate is, but glyphosate is a chemical which farmers use, particularly regenerative farmers have to use quite a lot because we don't cultivate, to kill weeds and to kill cover crops. And we're trying to move away from using a lot of glyphosate. So we've got this crafty technique. If I can get a -4 or a -5 degree frost in the winter and I get up early, I can roll cover crops in the winter when they've done their job, and they're basically, it's like glass and they just shatter to nothing. So in that top left-hand one, that's a cover crop that's sort of nearly waist high. That's me rolling it about 5 o'clock in the morning. I started much earlier than that while it was dark, but obviously I couldn't take the picture. And after a couple of weeks, on the top right there, you've basically got no material. It's just shattered to glass and decomposed. So again, it's techniques to minimize things that are harmful to the environment. Right, let's whiz through my soil health recipe card to the next one, which is returning crop residues to the soil to help build organic matter. So again, this is something you might notice if you're walking the Ridgeway in the summer. Some farmers will be rowing up straw, and there'll be balers there and turning it into bales and carting the bales. We like to try and chop as much as we can. This is actually a field right next to the Ridgeway at Scutchammer Knob. We try and chop and leave the straw on the surface as a carbon source, and it's really good worm food as well. We have a really high population of deep burrowing earthworms because I really look after them. In that you might or might not be able to see it, that left-hand picture is supposed to show worm middens. So again, this is something you can see if you look closely. In the winter, fields that have had straw chopped, you'll see lots of little piles. The deep burrowing earthworms come up at night and they basically spin round and gather the chopped straw and the residues and make it a little pile, a little midden above their burrow, and they gradually pull it down into the soil system and eventually it disappears. So instead of having to bale it and cart it off, the worms actually pull it underground for you. And it helps build soil organic matter. It doesn't help build soil organic matter massively brilliantly, because as the bugs are eating it, they're also breathing out carbon dioxide. So you get a massive explosion in the bug population in the soil that can eat the straw, but they're also breathing out. So some of what they're doing is breathing out carbon as well as bringing the straw into the soil. But ultimately, if you've got a lot of worms and you leave it long enough, you end up with that picture on the right. The straw's disappeared and you've got bare soil again. Again, this is the same field up by Scutchammer Knob. We do shoot ourselves in the foot trying to have a regenerative farming system sometimes. And again, it's not as easy as industrial agriculture. This is us planting crops after chopped straw, and crops don't like being planted in situations like that, cover crops. And oilseed rape as well doesn't like it. So we often get situations like this where the crop doesn't establish very well because we get a lot of slugs with a situation like this. And so it's got better and better over time. We chop the straw as small as we possibly can, and the soil system has got used to having a lot of straw, and I've got a lot of bugs that like eating straw in the soil, so it does disappear quite quickly, and we have got used to planting crops into it, but it's difficult. So again, you might see fields with a lot of straw on, but you also might see fields where the establishment isn't very good, and that's probably down to slug damage and chopped straw. Also, the chopped straw, when it breaks down, releases toxins that the new seeds don't like. But this is this is another thing that you might see, fresh crops growing in the autumn. The main picture is winter cereals in one of our fields growing through chopped straw. And so if you can imagine that compared to the inset picture is a more traditional way of farming, where the farmer might have ploughed the straw under to get rid of it, or he might have baled it off and carted it and done a lot of cultivation. So he's got very bare soil. It's very loose. It's been loosened. He's let a lot of carbon out of the system, because you'll see in a minute, by cultivating, we reoxidize carbon. We let oxygen in. It reacts with the carbon in the soil and it gets released as carbon dioxide. So the farmer in the inset has probably, while he's cultivated and ploughed, has let carbon out. His soil is also very prone to erosion if it's on a slope, because it's just bare. Whereas if you can see my fields, it's almost like a blanket on top of the soil, and it's protecting it. If there's heavy rainfall events, it's almost like stopping the impact on the soil. It's preventing erosion. And in the summer, it's also stopping heat. It's almost shielding from the sun as well. And it's providing a really nice ecosystem for things like carabid beetles that eat pests. So again, you might see crops like in the inset picture, which are more traditional. You might see crops that look very messy and horrible, and you might think, oh, that's a field that looks messy and horrible. There's a new crop growing, but there's loads of chopped straw there, but that's actually really good. Right, we're getting through it. This is quite a big one. This works on both sides. So if we just look on the right-hand side, I've got there, do not oxidize sequestered carbon by excessive cultivations, direct drill if possible. So traditionally in agriculture, farmers grew their crops and they were photosynthesizing, using some of the products of photosynthesize to grow, punching the rest through their root systems to feed the soil system and build soil carbon. And then in the autumn, the farmer would turn around and plough and cultivate and let it all back out again. So it wasn't great, but bearing in mind those old mixed farming systems back in the old days had a lot of grass, livestock, organic manures. So their whole farm system was building carbon. So the fact that they let a bit out didn't matter so much. But with the industrial systems of specialised arable, like I showed you that big picture at the start, it's quite important to look after the soil health to try and minimise cultivations. So we sequester it with photosynthesis, and then we direct drill if possible, or minimise our cultivations. And also on the left-hand side with the structure, we want to minimise compaction because we don't want to squeeze all the air out of the soil and compact it. And we don't want to work it when it's wet because that destroys its structure. So we have a technique we use on Hendred Estate called controlled traffic, which feeds into both sides of my healthy soil recipe card. Let's just think about machinery again. Bottom left, old-fashioned days, you might have a tractor and drill, it might weigh about 2 ton. Top right, you've got a modern tractor and drill, it might weigh about 30 ton. It's crazy how big and heavy this equipment is. And again, you see all this machinery running around on tracks, big wide wheels and big wide rubber tracks, and that's to try and minimise the pressure it puts on the soil. But if you think about it, that does minimise the surface pressure. But I always think of the fact of a wooden bridge across a dike, a ditch, and with soil on top of it, say a foot of soil on top of a wooden bridge. And you might take the little grey tractor in the bottom left-hand corner across the bridge, and the little narrow wheels might leave a big rut in the soil, but the tractor would cross the bridge. The big red tractor has got big wide tracks, so it doesn't leave such a big rut in the soil, but ultimately it can't cross the bridge because the bridge collapses. So it seems like you're doing a good job by not making a rut on the surface, but ultimately the axle weights are so heavy, you're damaging the soil. So to get around that, we do controlled traffic. This is what our trafficking used to look like. We used to basically drive over the field in different directions with lots of different width implements. And I worked it out once about 15 years ago. We were trafficking about 80% of the soil surface. What we do now, we use GPS and everything's 10 metres wide and we run on the same wheel tracks. So we've turned our 80% trafficking on its head and we only traffic 20% now, which means those big heavy machines aren't doing so much damage to the soil structure. And again, if you're walking on the Ridgeway and you're looking at fields at harvest time, you might see fields that look like this. This is a farmer that's not doing controlled traffic, so he's driven about all over his fields with heavy equipment. So now really to take the compaction out, he needs to cultivate to let air back in, but by doing that he'll also be letting carbon out and burning a lot of fuel. Whereas our fields tend to look like this. We've got 80% of them that have never been trafficked. So all we need to worry about is those wheelings. And it means that we can direct drill. So again, you might see fields along the Ridgeway on the Downs that look like that or look like that. And it'll be different farms with different systems. And then what we try and do is we try and either drill direct into these stubbles that haven't been trafficked with a disc drill that just punches the seed straight in without cultivating, or we just do a very, very light cultivation. So we're not letting the carbon back out. Right, sorry. I'm trying to whiz through this, so I'm talking quite quickly. Hopefully not too quickly. That's what it looks like in action. So there's a combine on the left, and then the previous combine track is being driven on by the tractor with the grain trailer. And then the previous track to that has been driven on with the tractor and the drill on the right that's drilling a cover crop to grow, to photosynthesize over the winter. So everything's on, just stepping over on the same set of tracks all the time. It's an amazing system. It really works well. Right, the last one on my healthy scorecard, then we'll get on to something else. This one I put in red. This is a bit nuanced, and I can't really bore you with this because this is too nuanced and it's a whole topic in itself. But I put optimize synthetic end use to minimize building and retention of, to maximize building and retention of soil organic matter. What does that mean? Right, synthetic N. Remember that thing at the start, that graph at the start I showed you where the food production line went up after the Second World War massively. This is a graph which shows how much the population of the world's been fed by synthetic nitrogen fertilizer, which matches the other graph pretty well exactly. since the Second World War, the rise in productivity is pretty well driven by synthetic nitrogen fertilizer, which is produced in factories using the Haber-Bosch process, which is really energy intensive. And it means there's a lot of nitrogen in the system, producing a lot of food. It's very energy intensive. That's our farm carbon footprint. That blue bar, the blue bars are emissions and the green bars are sequestrations. The biggest emission bar is basically nitrogen fertilizer. And this is really interesting. This is comes from something called the Stockholm Institute. If anyone's interested in problems with the planet, they've got this thing called planetary boundaries, and they've worked out these different boundaries and how they're being broken. And it's interesting because biodiversity loss and the nitrogen cycle are already outside the planetary boundary they're basically a worse situation than the climate crisis, which is still at the top there, sitting within the planetary boundary. The two biggest problems are biodiversity loss and the nitrogen cycle. And again, I'll just read that. The planetary boundary is set at 35 million tonnes a year of naturally occurring nitrogen in the atmosphere, converted to reactive nitrogen by human activities. And the actual level is about 120 million tonnes a year. Basically, there's so much nitrogen floating about that in all of our bodies, everybody here listening to this talk tonight, 50% of the nitrogen atoms in your body come from the Haber-Bosch process. 50% of the nitrogen atoms in your body come from that process. Basically, before the First World War, no nitrogen atoms in your body would have come from that. They would have all come from the atmosphere. Nitrogen is a problem. This is why our farming system tries to minimise use of it. Again, I'm not going to bore you with this slide, other than on the left is the note that basically, before we've even applied it to a field, production process has a high carbon footprint. That's a Haber-Bosch process. And then we apply it to a field. If we apply it judiciously on the left of that yellow diagonal line, don't bother reading the text because I'm just going to skate over this. But if we apply it judiciously, we grow nice big crops and we maximise photosynthesis and we maximise root exudates going into the soil. And I've put there, smiley face, soil organic matter increasing. But if we overuse it, which is what industrial agriculture tends to do, that's the devil with his fork there, we get nitrate leaching, we get nitrous oxide emissions, we get ammonia emissions, which are really bad. A nitrous oxide molecule is about 273 times more warming than a carbon dioxide molecule. So they have a much greater effect on climate change. And also, I can't go into the science of it, but we tend to burn out our soil organic matter if we use too much nitrogen. So it's almost like that yellow line shows it's a very delicate balance, nitrogen is, and our farming system tries to minimize use of nitrogen, but it's very hard because we're trying to make a profit and it's quite cost effective to use. I'm getting through it now. It gets better in a minute and less heavy and more pictures. This is just one last slide on nitrogen. We obviously try and use legumes as much as we can. 78% of the air around us is nitrogen, and legumes suck it out of the air free for us and put it in the soil. So on the top left there, that's growing a companion crop with oilseed rape, which is a legume, Berkshire clover. On the top right there, spring barley with a clover understory to try and sequester some nitrogen out of the air, and then just trying to mix legumes into the system by mixing them in with other crops, by drilling beans with oats or beans with barley or wheat. And this is one that we've been trying for quite a few years, that we have by the farm buildings, a clover understory, which is almost the magic dream if this works. You have a field of white clover, which basically is taking nitrogen out of the air all the time and sequestering carbon into the soil. And it's also a bit of a weed suppressing mulch. And you just keep direct drilling a cash crop into it and keep harvesting it. It's not quite as simple as that, but it's something that we do. So if you do see fields with a stubble that's got a lot of clover in the bottom, maybe it's somebody trying to minimize their nitrogen use and think of different ways of cropping. Right, sorry, quick breather. I'm just randomly going to talk about a few other things now. Biodiversity and complexity. Why would we complicate nice, simple industrial farming with biodiversity and complexity and making homes for beneficials? Industrial farming is way simpler. So why do we want to go away from it? Well, for various reasons. I've given you the factory premises analogy. It's basically the biodiversity around us. As we saw, it's already broke through the planetary boundaries, biodiversity loss. It's one of the ecosystems we're working with, and we've damaged it. Industrial agriculture, we have to repair it. The sprays don't work anymore, insecticides. So we're relying on beneficials much more than we were to control pests. And also mindset change. I'm a beekeeper and I don't want to kill bees. So we just don't spray against pest problems. We don't use insecticides. If you see us spraying, we're either spraying fungicides or herbicides. We don't spray insecticides. We want to look after our lovely bees. Sorry, I love getting little photos of bees in. But this is another nice, funky little fact. I love little facts like this, but I keep digging up interesting things about bees. Top left, nothing to do with my talk really, but you might find it interesting. Not only do bees go and pollinate our crops as they're foraging around for pollen and nectar, but it's actually really more interesting than that. As they're flying through the air, the friction of their wings and then moving through the air, they generate a positive electrostatic force, and pollen is negatively charged. So when a bee lands on a flower, the pollen actually jumps. It's electrostatically attracted like a magnet to the bee. One's negative, one's positive. You might have all known that, but I didn't until recently. Nature's fascinating. That's why we need to look after it. To try and help maintain our factory premises and look after the ecosystems, we try and put flower strips where we can. And traditionally, a lot of farmers, again, you might see this on fields close to the Ridgeway, a lot of farmers have put flower strips, grass margins and things as habitat around the edge of fields. But what we've tried to do is actually put them down the middle of fields. This is an interesting field. Actually, there's a black and white photo of this on Scutchammer Knob car park on the Ridgeway. There's a series of Ridgeway 50 photos that Matt Whittle did, and he's posted all along the Ridgeway. One of them is a black and white of this field. These are flower strips, the two light green strips down the middle of the field. They look like that. The idea is to actually bring the habitat right into the field so the beneficials can pollinate the crops better. The ladybirds and things can go out into the field and kill the aphids in my crops. The carabid beetles that are living in the bottom of these strips can walk out into the fields and kill the slugs. So it's basically trying to look after nature, but trying to do a useful job helping me grow my crops as well. So we try and have a lot of these around the farm. I'd like to have more, but there's a few problems with them. DEFRA have messed around with the funding for environmental schemes. And as I showed at the start, farmers don't make very much money. So it's quite hard to fund this factory premises maintenance out of profits. We almost need handouts from DEFRA to help us do environmental jobs. And also a lot of the local neighbourhood horses use them as gallops and destroy them. So some of the ones around the edges of some fields I've had to actually rip out recently. But we do really like our wildflower strips, particularly down the middle of fields. This is super interesting. I put some sticky traps up. The top left sticky trap was in the middle of a wheat prairie in the middle of June time, and it got loads of insects on it, but they're all one type of insect. I'm not an entomologist. They were, most of them were black and they looked the same, pretty well identical. There was loads on there. They were little black nondescript things. I put another sticky trap next to one of my infield flower strips, and it was unbelievable. You can't really see it there, but basically the diversity of insects on it was unbelievable. They were purple, green, turquoise, black, different sizes, different shapes. It's amazing the biodiversity, how it increased by putting these flower strips rather than just having wheat prairies. They're also great for the deer as well. Bottom left, we get a lot of deer damage. You'll see a lot of deer on the downs, on the farmland around the Ridgeway, and they're not all good for farmers. They eat trees and they damage crops. That bottom left is where we're combining a crop, and deer have been lying in the crop and flattening it. But we find with the strips, those other three pictures are showing deer on the strips, and they stand on the strips and they graze on the strips and they tend to lie on the strips. So we get less crop damage. So as an indirect effect of the strips, the deer damage has dropped, which is good. Biodiversity, again, I'm still on biodiversity. I'm going back to grass now quickly. I've probably only got 5 minutes left and I'm done, so we're getting through it nicely. That's a happy ewe in the spring. It's on single species perennial ryegrass, fertilized with a lot of synthetic nitrogen. The other problem with perennial ryegrass lays, if you look at the inset, is with these dry, hot summers with climate change we're getting, they drought out really badly. If it doesn't rain, they've got shallow root systems and suddenly you've got no grass for your stock. What we're trying to do, again, this is on the theme of biodiversity and sustainability, we're trying to turn our grass fields over to herbal lays, multi-species herbal lays. It's the same argument as the cover crops. If we've got loads of different species in the mix, it's good for soil health. But it's also brilliant in a dry time because some of these herbs like chicory, they're super deep rooting and they go right down. And when it's a droughty time and your perennial ryegrass lays are brown, the herbal lay fields are still green. So again, in my I Spy theme that I'm trying to run through the talk, if someone's I spying as they're walking down the ridgeway and you're seeing grass fields that are brown, and then in the summer, and then you see a grass field that's green with sheep on it eating happily or cattle, it's probably a herbal lay. The other giveaway is the flowers, particularly the chicory. The chicory's flower a beautiful purple, purpley blue. The other great thing about the chicory is they're natural wormers as well. So when the sheep eat them, it's like a natural wormer, so you don't have to give them artificial wormers. So again, they're great herbal lays, and hopefully we see more and more of herbal lays on the farmland around the Ridgeway and on the Downs. Nearly done now. This is just a bit random. This is another way that I view how I integrate my food production line with maintaining my factory premises, the ecosystems that I'm working in. How do I square off the two things? And this is, I like visualizing things. So this is how I visualize it in my head. I've got my little plate of food production and it's propped up with 3 legs. So it's a plate or a stool or whatever. And it's propped up with 3 legs, which I call hedges and edges, crop nurturing nature, and spaces for species. So they're all my factory premises and the food production is my production line. My hedges and edges is basically what we try and do around the edges of the field. So we're not really impacting our food production line. We've got flower margins around the edges. We're planting new hedges. That's one down by the trees, top right. That's a grass margin on a shady bit of the field where the crop never ripens very well. So you've got nice factory premises maintenance going on, but it's not massively impacting your food production. So it's a bit of a win-win really. So that's my hedges and edges. And then I've got my crop nurturing nature. And these are the things that we can help nature and run our food production line, but nature is sort of helping us and it's almost replacing our environmentally damaging inputs. So we've got our top left, we've got our flower strip in the middle of our fields, which is hosting our beneficials, our ladybirds eating aphids, our carabid beetles eating slugs, our bees and parasitic wasps and everything pollinating our crops. We've got a legume fallow on the bottom left, which is basically building fertility for the next wheat crop. We've got our clover understory, top right, which I've already alluded to, which cuts fertilizer and herbicides. And we've got our bicrops. That's a bean, oat bicrop. The interesting thing with bicrops is that they confuse diseases and predators. So if you've got a field of beans or a field of oats, and then you put both of them together, you get less disease and you get less pests because the oat diseases and pests are a bit confused because there's beans in the field, and the bean pests and diseases are a bit confused because there's oats in the field. So you minimize the damage from pests and diseases by mixing the crops up. This is why the Brazilian rainforest, the Amazonian rainforest, never gets killed by pests and diseases, because there's so many species there, nothing ever gets out of control. So that's my crop nurturing nature. And then the last one, nearly done, about 2 or 3 slides, spaces and places for species. Bit of a tongue twister. That is a BNG scheme I've got going on at the top. So what I've done is I've found, this is almost like rewilding. We've found a bit of the farm where we can say, let's not do food production on this. Let's just leave this for nature, but actually we're getting an income from it because we can't afford just to leave it for nature. So it's, if you like, it's propping up our farm profit, and it's a biodiversity net gain scheme. So just to let you know what biodiversity net gain is, hopefully people know about it. But basically, since February last year, the law is that any developer, anyone building houses or doing developments, has to have a 10% biodiversity uplift on the site. And so those bottom two pictures, left and right, the developers have basically built the houses, and then they've done the biodiversity uplift on site. They've planted flowers, they've dug ponds, they've planted trees. But some developers don't want to do that, and so they go into partnership with a farmer. So farmer there on the top left, shaking hands with the developer there, doing a deal, and he's sold biodiversity units to the developer. So the developer washes his hands of doing any biodiversity uplift on his site, and he buys the biodiversity uplift off a farmer. And that's what we've done. So that's a view. This is not far from the Ridgeway. I don't know if you can see my pointer, but my pointer is that Scutchammer knob. This is the West Ilsley side, and the area within the fencing is trees, and the other bare area is chalk grassland. And we've done another one since then. So we've got quite a big area here, which is generating as much money as the farming, and it's a 30-year scheme, but it's also giving me my spaces and places for species, which is the third leg of my little stool. Right, nearly done. Spaces for people too. So we take our public access seriously. We've obviously got the Ridgeway running through the farm, which we like to keep nice, and we like to keep all our bridleways and footpaths nice as well. That top left is interesting. I try and put hedges or wildflower strips between footpaths and bridle paths and the crops, so it keeps people away from sprays and things. So if we're spraying, again, it minimises the impact on bystanders. And again, this is a bridleway on the bottom right there, next to the atomic energy site at Harwell, which was horribly rutted. And we power harrowed it and reseeded it and made it really nice, although it's been destroyed by horses this winter. So yeah, it's spaces for species, but people are species. So on the farm, we're trying to look after the people as well. Last two slides. We've got a lot of windbreaks and trees, so we're gradually, again, increasing the biodiversity. A lot of them are coniferous, so we're gradually felling the conifers and putting native broadleaves in instead. So over the next 50 or 100 years, the biodiversity will be much more diverse in the trees that we've got. And we're also trying to plant new hedges where we can with grants and things. There's some new hedges that have gone in recently. Phew, I finished. Sorry about that. I felt that I went like mad because I had an hour and I didn't think I could do it in an hour, but I've just about done it. This is my finished slide. I just love this little quote. For all our technology, it still takes personal care and attention to grow food productively, environmentally, and even beautifully. And doing this must surely be the most inherently positive ways that a person can spend their time on the planet. Basically, what we're trying to do in red is, on the Hendred Estate, is grow food productively, environmentally, and even beautifully. But we're not the most amazing example of regenerative agriculture on the planet. I've got constraints. I'm trying to make a profit. It's not my farm. I'm a manager. So you might look at Hendred Estate if you're walking on our footpaths and say, oh, well, I've been on farms that look much nicer and more environmentally friendly than this. But what I've tried to show you is what I'm trying to do and give you a pointer for things that you might see on farmland in and around the Ridgeway going on, things like direct drilling, cover crops, herbal lays, etc., control traffic, that are new ways of farming in harmony with nature, if that makes sense. I'll stop now.
Well, thank you, Julian. That was absolutely amazing, and I think you can tell from people's reactions there that it was brilliant. Thank you. It was fantastically interesting and beautifully presented and so well explained. I genuinely feel like you've shown me the light. I feel like I'm joined the cult.
Okay.
So thank you very much. Particularly like the stock figures that really illustrate what drove industrial farming and I really like the the factory premises analogy as well. I mean, it's great, and the apple, obviously. But
I can eat
just
that
waiting
now.
for. Sorry, Jim.
Sorry.
Just waiting for some questions now. Um, an awful lot of people saying how great the talk was. Um, um, so I can't read my own handwriting. How embarrassing. Well, first of all, I didn't know you were a beekeeper, and thank you for that. The electrostatic charge is completely new to me, so thank you. Bringing things back to archaeology, which is what I always tend to do. I mean, this is all fantastic news for us. Retaining soil and detecting irreplaceable archaeological deposits and lessening compaction and direct drilling, so there's no inversion of the soil. It's brilliant. Do you think there's along with carbon sequestration, do you think you're deepening and restoring the soil as well? Do you think we're getting some of that soil that may have washed off in the past back?
Yes, yes, this is a good thing. It is actually relatively easy and relatively quick to restore soil. All these newspaper headlines you see where there's 60 years of soil left in the world and then it's all gone. If farmers see the light and have regenerative systems, you can build carbon in soils. It is a slow process, and it can be sped up by we're doing it. That healthy soil scorecard recipe card is a recipe card that's pertinent to my farm here. And now different farmers might build a different recipe card. And on the right, you might have application of compost, farmyard manure, biochar. There's ways you can build the soil quicker. You might have more livestock. We're a predominantly arable farm. You might have more livestock and lots of farmyard manure and lots of rotational grass. Grass builds organic matter quite quickly. So there's ways and means of building soil more quickly or more slowly. But soil is building, and the depth of soil is building gently as well, potentially.
Yes, thank you. That's really interesting. I've got a question from Lucy. Do you feel your approach to farming and encouraging biodiversity is common, or do you feel like the Hendred Estate's an outlier?
No. It's getting quite common now. We were actually 10 years ago. We were probably one of the at the forefront ish, not ish. We've never been properly at the forefront, but people are getting the message on regenerative agriculture, particularly all the young people in agriculture, because a lot of agriculture is run by old people like me that were trained in the 80s, and basically we were trained in industrial agriculture techniques. Basically, pile as much nitrogen fertilizer and pesticides on as you can to grow as much crop as you can. No one even mentioned environment in the 80s or 90s. It was a word that never passed a farmer's lips. Youngsters now that are taken over from their parents and young farm managers get it, and regenerative agriculture is a massively growing. It seems to be growing exponentially. But the trouble is, we need to get the message out there even faster because there's so much damage being done as climate change, biodiversity loss, nitrogen cycle, as we see on those planetary boundaries. We're already blowing them all out the water. So it is happening quite quickly, but it needs to happen quicker, if that makes sense.
It's perfect sense, and I think a good start would be for everybody, absolutely everybody, to watch your talk when it's uploaded to YouTube. Brilliant. A question from Susie. What effect have you noticed on profit per hectare over the years as you've implemented these changes on the farm?
I'd say it's lower. Okay, this is a problem. It's the government environmental schemes that came out a couple of years ago were really good because they started paying for this environmental work as the main subsidies were dropping. But the problem is, Dan, with sustainable agriculture and nitrogen and pesticides. So pesticides are too cheap and nitrogen's too cheap because they're a bit like my little man thinking about externalities. Nobody factors in the environmental damage and the carbon footprint into the cost. So in the short term, it's much more profitable to pile on loads of nitrogen and to use insecticides and lots of pesticides. Insecticides are as cheap as tap water. So your average agronomist, we don't use insecticides, but your average agronomist will just chuck them in anyway when you're going through spraying something else. I shouldn't broad brush that, not your average agronomist. Some agronomists will chuck them in even if there's not necessarily a pest problem. What needs to happen is that there needs to be a tax on an environmentally damaged tax, or a carbon tax on the inputs, or there needs to be government regulation or quotas on nitrogen fertilizer. There needs to be regulation, but the problem with regulation is, unless it's global, it doesn't work. For example, they banned neonics in Europe and the UK, which was a harmful insecticide that we used to use in oilseed rape. And what happened was we couldn't grow very much oilseed rape because the insects were eating it all. And we imported oilseed rape from the Ukraine and Canada, who were both allowed to use insecticides. So we put ourselves at an economic disadvantage. And if you like, we exported our environmental damage. It's a real conundrum. In the short term, regenerative agriculture is less profitable than industrial agriculture. I think I can say that quite safely. But it makes you feel a whole lot better.
Yeah, indeed. But the point you made about borrowing the fertility of or even stealing the fertility of the soil from future generations was very clearly and starkly put. Thank you. Another question from Lucy. Also, as somebody who's walked and camped the entire Ridgeway, are you happy for people to respectfully wild camp along the route that you steward?
Say that again. Am I happy?
As someone who has walked and camped the entire Ridgeway, are you happy for people to respectfully wild camp along the route that you steward?
Oh, that's an interesting one.
Yeah.
Because I'm not sure we have jurisdiction over the Ridgeway. It's an interesting one. The Ridgeway, as it passes through farmland, I've never been clear on this, whether I don't think we've got jurisdiction on it. I think people can do what they like. I don't think it's anything to do with us as it passes through our farmland. The actual Ridgeway itself, it's, I don't know, it's owned by the government, is it? It's technically on our land deeds. I'm not sure how it works, but I don't feel I've got jurisdiction over the Ridgeway.
Ian, sorry, everybody. Ian Black, the Ridgeway officer, and I have discussed this actually, because some sections seem to fall within. Well, they're owned by the estates, or but who's the responsibility for? It's really complicated. Sorry, I haven't clarified that before. But another question from Susie. My 7-year-old son asks, "You keep talking about earthworms. What about normal worms?"
Earthworms are normal worms. There's 3 types of worms, earthworms. There's anisic, endogeic, and I've forgotten what the other one's called now. Anisic, endogeic, and sorry, I'm having a senile moment. Yeah, there's the deep burrowing ones. Earthworms are normal worms. Yeah, there's the deep burrowing ones, and there's the shallow ones that live on the surface, and the ones that sort of live halfway down. They do slightly different jobs. They're all worms.
You tripled my knowledge of worms anyway, so thank you, Julian.
Yeah.
If you don't mind, I'd quite like to ask another question, if that's all right. While we're waiting for more.
Yeah.
With the countryside stewardship schemes and the new schemes that are coming through, do you think they sufficiently take account of the statistical and evidential base that you've created here on the estate and that other farmers have created in other places? Do you think that's sufficiently taken into account with regard to payments, whether they're revenue payments or capital payments?
I mean, I'm confused by the question. Do I think there should be revenue or capital?
Oh no. Do you think that in their the creation of the schemes,
Yeah.
or in the reflection of what people have to do through payments, do you feel that the work of this kind of regenerative farming and how you've evidenced it is sufficiently taken into account? Do you think that do you think that the payment is of a requisite value to the work you do.
Whether the payments are high enough, I think you're asking.
Yes, that would have been a much better way of putting it. Thank you, Julian.
Some of the payments are too low and some are too high, in my opinion. The SFI got it quite right, but some of the payments were too high and some were too low. They're not far out. Most of the payments nearly cover the cost of doing the job, and some of them more than cover the cost. It's not far. The SFI wasn't far out, but of course now it's going to be capped and limited, and some of the payment rates have dropped for 2026. It's basically the coffers have run dry a bit, and it's not going to be quite as good as it was, and so there'll be less environmental work done because farmers. It's like I was saying, regenerative agriculture is in the short to medium term, it's slightly less profitable. You need to want to do it. Now, I need to qualify that answer to that earlier question when I said it's less profitable. In the medium to long term, it'll be sustainable because ultimately with climate change and fossil fuels running out and legislation to stop us using, we're losing pesticides all the time because they get legislated against and the regulatory bodies withdraw them because they're dangerous to the environment and things. So we're losing tools. Industrial agriculture is losing tools all the time. And so ultimately, at some point in the future, regenerative agriculture and sustainable systems will be more profitable. I don't know why I said that. Sorry, I don't know what question I'm answering now.
That's because my attempt at a question was so long-winded and rambling. But thank you. Your answer was superb. Mary's just pointed out there's another question in the Q&A from Craig. Min-till, no-till has clear soil health benefits, but the use of herbicides, Roundup, is often increased to manage end-of-life crops. How can the damage caused to soil biological health be mitigated?
Oh yeah, it's a difficult one. Glyphosate is I've got a 2-hour glyphosate talk that I do. Glyphosate is a whole topic in itself. It's meant to be the world's safest herbicide. There's loads of lawsuits going through America at the moment with Monsanto and Bayer about its cancer-causing potential. But the biggest problem with glyphosate, so regenerative farmers rely on it. This is a real conundrum. Regenerative farmers aren't cultivating. They're not damaging the soil structure. They're not damaging your archaeological artifacts. They're not letting carbon out. They're doing loads of great things, but then they're having to replace those cultivations that were killing weeds in the old days with glyphosate. Glyphosate's biggest problem in the environment is its antibiotic effect, not the fact that it might cause cancer. Acutely, it's not very dangerous, but it's an antibiotic. So all that lovely soil microbiome that I was telling you about with the 7 billion organisms in my teaspoon of soil, they're being harmed by the antibiotic effect of glyphosate. So we need to minimize our use of glyphosate. What I do is try and minimize my use of glyphosate by techniques like that rolling in the frost. That's a really good technique. You need a really low rate of glyphosate to kill a little bit that's left then. And also we put molasses, basically black treacle, with our glyphosate sprays. So we're damaging the soil microbiome, but at the same time we're feeding it. So if you like, we're hitting it on the head with a hammer and then giving it a sweetie. So we're trying to mitigate our damage by feeding it with molasses. So there's techniques to try and minimize the glyphosate effect. The end of life thing that was mentioned in that question, I think they were alluding to sunshine in a can. Roundup is also called sunshine in a can because you can desiccate crops to help them ripen quicker, which is a really bad use of glyphosate and will ultimately be banned. I think it's banned in Europe now, and it'll gradually get banned. So glyphosate will only be able to be used as a weed killer early on in the crop's life. Glyphosate is a problem, but everything in life is a trade-off, Dan. Everything in life is a trade-off. We're trading off cultivations and the damage that does for a herbicide and the damage that does. And it's a case of weighing up which is the least bad.
Julian, that's really interesting. Well, all of nature is a balance, isn't it? I suppose. But I don't think we have any more questions. But sorry, I'll just quickly check, and just more people saying what a great talk it was. So, thank you very much, Julian. I'll be sending that the link to the talk round to all the teams in Historic England, because I think this is something we should all be aware of, or more aware of, certainly. So thank you very much for your time and such a well considered and presented talk. It was really brilliant. Thank you. I'll let you have your evening back now.
Say that again. Sorry.
I'll let you have your evening back now.
Oh yeah, lovely. Thanks.
Thank you very much.
I can eat my apple now.
Excellent. Cheers. Thank you very much, everybody, for coming. Bye.
Bye.